Hello and welcome to the next session, and today we are going to talk about what we call as a mining various kinds of association rule. And last time I explained you about the frequent set mining. Now there was one example I would like to again take it, and this was the example of the last time remaining. So I am showing you another example where a priori algorithm which we spoken last time, we have understood last time. Again one more example I am giving to you. Okay, you can see that example with a minimum support, item set, then count, and then finally the last scale. So with this you can have the confidence level, you can calculate the data set is already shown here, and you can calculate the confidence level of all the items I1, I2, I3, I1, all the items put together. You can calculate the confidence level, and you can see that some of the confidence level of I1, I2 is 100%. That means every item set I1 and I2 will be occurring. Now with this information as a background which was remaining last time, let us go to a last topic of our unit called as mining various kinds of association rule. So how do you mine various kinds of association rules in the data science? So let us consider an application requirement by extending our scope to bring mining multi-level association rule, multi-dimensional association rule, and quantitative association rule in transaction or a relational database. So the topic is very vast. However, we limit ourselves to including the multi-level association rule and sometime multi-dimensional. Okay. So multi-level association rule involve concept at different levels of abstraction. Very simple definition. Levels are different, and when the levels are different at different levels of abstraction, the confidence level or association rule will keep on changing either, or it will remain the same. Second is multi-dimensional association rule involve more than one dimension or a what we call as a predicate. For example, rule relating to a customer buy as well as a customer age. So you have a multi-dimensional. Okay, and the third is quantitative association rule involves numeric attribute that have a implicit ordering among them. For example, age is a natural order. So with this background, let us see what is meaning by mining multi-level association rule. So for many applications, it is very difficult to find a strong association among the data item at low or a primitive level of our abstraction due to the sparsity of my data at those levels. Sparsity means they are occurring but not frequently, not coming regularly. Strong associations discovered at high levels of abstraction may represent common sense knowledge. However, what may represent more common sense to one user may seems to another one as a novelty. So therefore, data mining system should provide a capability of mining association rules at multiple level of abstraction with a sufficient flexibility for ease of traversal among different abstraction levels. So let us see an example. Now if you look at the table, transaction ID 100, 200, 300, 400, 500. Items which are being purchased by the customers are IBM ThinkPad machine or IBM ThinkPad laptop, HP Photo Smart, Microsoft Office. Transaction 300 contain Logitech mouse, cordless mouse, and all those things. And finally, in the table 500 contain same thing, something like that. Now, if I look at the table, can I make a concept hierarchy? So let us make a hierarchy. At level number 0, everything comes in. So level number 0. Level number 1 will be computer, software, printer and camera, and computer accessories. So this is the next level of my hierarchy called as level number 1. Under the category of computer, I may have a laptop, I may have a desktop, or I may have a palm top. Level number 2, and under level number 3 I can have a laptop coming from a IBM company, desktop coming from a Dell computers or any other manufacturer. And finally the level number 4 will tell me which is the computer. So if you look at the level 0 is your root, level 1 is a branch where different items are being projected. Level number 2 tells me okay which is the particular item, and level number 3 tells me the brand, and finally the level number 4 will tell me the exact detail about the brand. So The concept hierarchy of figure has 5 levels, respectively referred to as a level number 0 to 4, starting with level 0 at the top. Note for almost general abstraction level, and here level number 1 include computer, software, printer, camera and computer accessories, and level number 2 include laptop, desktop and all those things. Okay. So, this is what the hierarchy is all about. Just now I told you. Now, association rules generated from mining data at multiple levels of abstraction are what we call as multiple level or multi-level association rules. Multi-level association rule can be mined efficiently using a concept hierarchy, because I am going from level 0 to 1, 2, 3, 4 under a support confidence framework. In general, a top-down strategy is always employed, where counts are accumulated for the calculation of frequency item set at each of the concept level, starting at the concept level 1 and working downward in the hierarchy towards a more specific. So, I go from a generic to more specific level until no more frequent items can be found. So, for each level, any algorithm or discovering frequently item set may be used, such as a priori or its variation. A number of variations to this approach are described, okay, and which we will see here in the figure I am taken from the book. So, these are the two figures, okay, from chapter number 15 of our book called Data Warehousing and Mining by Hahn and Camber. Okay. So, in chapter number 5 here they have described each and everything, okay, I have taken from that book itself. So, using uniform minimum support for all the levels. Now, let us say I have level number 1 and level number 2, and I put a uniform minimum support equal to 5% at level number 1 and level number 2 also the same support. So, we use the word uniform support or uniform minimum support. Okay. So, for example, a minimum support of threshold of 5% is used throughout, for example, mining the concept down to the laptop computer, but both computer and laptop computer are found to be frequent, while desktop computer is not found. Okay. So, this is the answer. And when a uniform minimum support threshold is used, the search procedure is very simple, and the method is also very simple, in that users are required to specify only one minimum support, which is a threshold value. A priori like optimization technique can also be adopted based on the knowledge which we have on the ancestor in a superset of his ancestors. So, the search avoids examining item set containing any item whose ancestors do not have a minimum support level. Okay. So, with this minimum support, everything become a uniform. However, there are some issue and some problem. The problem is very simple. The uniform support approach, however, have some difficulties. It is unlikely that items at lower level of abstraction will occur as frequently as those at the higher level of abstraction. So, this is the underlying problem. So, if the minimum support threshold is set too high, it could miss some of the meaningful association occurring at low abstraction level. However, if the threshold is put very low, it may generate many uninteresting pattern or uninteresting associations occurring at a higher level of abstraction. So, the problem. So, this provide a motivation for a following approach. Approach is very simple: multi-level mining with reduced support. So, using reduced minimum support at lower level, referred to as a reduced support, each level of abstraction has its own minimum support. So, you can see here level 1 has 5%, level 2 has only 3%. So, it is reducing 1. So, for example, the minimum support threshold at level 1 and 2 are 5 and 3 respectively, and in this way computer and laptop and desktop are consistently or more or less considered as a frequent item set. Okay. So, this is the another example. Now, moving to the last topic of our unit called as constraint bend association mining. Now, we can we put a constraint, and what is the meaning by the constraint association mining rule? Let us see. So, a data mining process may uncover the thousands of rules from a given set of data, most of which end up with being unrelated or uninteresting to the user. However, users have a good sense of which direction of mining may lead to a interesting pattern and the form of pattern or rules they would like to find out. Thus, a good heuristic is to have all users specify such intuition or expectation as constraint to confine the search space. This strategy is called as a constraint based mining. So, let us see the example. First type of constraint is knowledge type constraint. This specifies the type of knowledge to be mined, such as association or a correlation. Next constraint is data constraint. Specify the set of tasks relevant data. Dimensional constraint. This specify a desired dimension, for example, attribute of the data, level of the data, concept hierarchy to be used in the mining purpose. Then we have interestingness constraint. Those specify threshold on the statistical measures of the rule of interestingness, such as support, confidence, and the correlation. And rule constraint. These specify the form of rules to be mined. Such constraints may be expressed as meta rules, that means applied from all the template, applied to all the places. So, it is called as a template or rule template. As the maximum or minimum number of predicates that can occur in a rule antecedent or consequent, or as a relationship among attribute values and or aggregates. So, with this I have given a overview about the different level of constraint mining, multi-level mining and multi-dimensional. We have not talked about multi-dimensional mining, but it gives me a very beautiful idea about the constraint, how to mine at level number 1, 2, 3, 4, 5. So, with this I end unit number 4. Thank you.